Hey everyone, today we're going to talk about amortized loans. So we need to know how to calculate the payment to pay off an amortized loan, construct an amortization schedule, find the present value of an annuity, and calculate the benefit of refinancing a loan. So what is an amortization? Well, it is the process of paying off a loan plus interest by making a series of regular equal payments. And such a loan is called an amortized loan. So if you think about your credit card, you can make any payments of any amount and any time. Well, amortized loans were quite different, and it is more like your car loan or a mortgage. So now you're going to see a formula for finding payments. It might look scary in the beginning, but it is really easy to read it. So assume that you borrow an amount P, which you will repay by taking out an amortized loan. You will make M periodic payments per year for N total payments. And the annual interest rate is little r. Then you can find your payment by solving for capital R in the equation above. Let's do an example. Assume that you have taken an amortized loan for $10,000 to buy a new car. The yearly interest rate is 18%, and you have agreed to pay off the loan in 4 years. What is your monthly payment? Well, let's see what we know, what is given to us in the statement of the problem. So we need to answer several questions. How much have you borrowed? This quantity will be represented by big P. And in our problem, we know that we're going to borrow $10,000. So capital P is 10,000. What is the annual interest rate? Little r. The problem says the interest rate is 18%, and let's convert it to the decimal 0.18. How often are you going to make payments? We will denote this information by little m. Well, we're going to make payments every month. So we're going to make monthly payments, and since there are 20 months in a year, m is going to be 12. How many payments are you going to make in total? You're going to make 12 payments per year for 4 years. So this information will be denoted by little n, and 4 times 12 is 48. And the last question, how much is a regular payment? It's a capital R. Well, this is what we need to find. So let's do some algebra now. We're going to substitute all known variables into the formula. Recall that capital P is 10,000, little r is 0.18, n is 48, and m is 12. So once you substituted all these variables into the formula, it will look like this. We need to simplify this expression in order to find big R. Well, first compute R over M, because this quantity appears in your formula 3 times. Well, in this particular case, R over M is 0.18 over 12. And if you do division on your calculator, you will get 0.015 and substitute it back. So now your formula looks a little bit easier to comprehend. Next, we compute 1 plus R over M to the power n, because this quantity is shown twice in your formula. Well, let's see. We computed R over M previously, so now we just need to add 1 and raise that quantity to the power 48. And in this particular case, the answer is going to be 2.043478 and so on. Please do not round any quantities until the last step of the problem. With this simplification, our formula looks like this. Now we can simplify the right-hand side of this expression. Finally, this is the expression we were looking for. Now, don't forget that we're looking for capital R. How can we find it? Well, you need to divide both sides of this equation by the number attached to big R, which is 69.565, so on and so forth. So after dividing through by 69.5652 and so on, your R will be 293.74999. And at this point, you can round to the nearest cent. Therefore, your monthly payment is going to be $293.75. Okay, let's do another example. The Cullen family wishes to borrow $200,000 to finance a new summer house. They have obtained a 30-year mortgage at an annual rate of 6%, which has a monthly payment of $1,199.10. Construct an amortization schedule for the first 3 payments on this loan. Now, let's imagine that you borrowed $200,000. You already know your monthly payment, so we don't need to look for this information. This piece of information is given to us. So every single month, you're going to send a check to your bank for $1,199.10. Hopefully, in 30 years, you will pay off your loan completely. Plus, do not forget that you have to pay your bank the interest. So, with every payment you make, you will make a payment against the principal, and you also pay off some interest. So, let's see. So, you're making a payment of $1,199.10. This payment will be split. Something will go against the interest, and something will go on principal. So, let's compute how much we owe the bank for the first month. Well, you owe, by the time you're making the first payment, you actually owe $200,000. And you owe that quantity for the whole month. You know that the annual interest rate is 6%. So what is the interest rate for just 1 month? Well, you need to divide annual interest rate by 12, and then you will get a monthly interest rate. So in this case, monthly interest rate is going to be 0.005. And if you multiply the amount you owe by this monthly interest rate, you will get interest amount for the first month. $200,000 times 0.06 divided by 12 is 1,000. So you actually owe your bank $1,000 for having $200,000 in your hands for the first month. So 1,000 will go to your bank. This is interest paid. But your payment is a little bit bigger. So the difference, which is just $199.10, will be going against the principal. So now, after paying $199.10, your balance will be reduced by this quantity. So after making the first payment, your balance will be $199,890. Note that only $199.10 were paid on principal, and the whole $1,000 was the interest. It is now time to make the second payment. Since you paid already $199.10 on your principal, your balance is reduced, is no longer $200,000. Now it's $199,890. So now it is time to make the second payment. Again, the amount of payment remains the same. You make the same payments every month. So let's see. Again, this payment will be split. Something will go against the principal. Something will be going against the interest. So let's see how much you owe your bank, how much interest accumulated on your account. Well, now you owe a little bit less. It's not 200,000, but less. 199, 800.9. Again, how much you owe your bank, how much interest accumulated on your account for 1 month. You know annual interest rate, which is 6%. In order to find monthly interest rate, you just divide annual interest rate by 12. So after doing multiplication, you see that for the second month, you owe $999 in interest. What's the difference? Because you paid slightly more. And the difference in this case is going to be $200.10. And this quantity will go against the principal. So your balance will be reduced by $200.10. So now you owe $199,000, 680 cents. Again, you see you made the second payment. Now more money went on principal and just $999 was interest paid. So after two payments, which is about $2,400, your balance was reduced by only $400 approximately. Now you're making the third payment. Again, payments are going to be the same. So let's see. For the third month, since you reduced your balance twice already, your interest is $998 that you have to pay. Whatever is left, and in this case it's going to be $201.10, will go against the balance. So we can summarize our findings in an amortization table. This table contains information about each payment, what's the portion of your monthly payment will go against the principal, and how much will go against the interest, and your balance. When paying off a mortgage, you may be discouraged to see how much of the early payments go toward interest. However, each month the principal decreases, so as time goes on, less is paid for interest and more toward the principal, which means that the bank will take its money first, and then it will reduce your balance. So after making 240 payments, so it's after 20 years of holding this mortgage, which means that after 240 payments, you paid $287,000, $784, which is more than you actually borrowed. Your principal balance will be over $100,000, which means that you paid more than you borrowed and you still owe more than a half. If we know the monthly payment, the interest rate, and the number of payments, then the amount we can borrow is called the present value of the annuity. We're going to use absolutely the same formula for finding the present value. However, in this time, we're going to solve for big P. So assume that you borrow an amount P, which you will repay by taking out an amortized loan. You will make M periodic payments per year for N total payments. And the annual interest rate is little r. Then you can find your payment by solving for P in the equation above. So just assume that every month you have some extra money in your pocket, maybe let's say $200 each month. So you called your bank, and the bank offered you a loan to buy a new car, and with an annual interest rate of 12%. So now the question is, okay, you're going to spend $200 each month for 4 years. How much you can spend on your car right now? Because in the end of the 4 years, you have to pay off your debt, plus you have to pay off interest. So again, we need to see what kind of information we're given. So we have to answer several questions. How much you can borrow, and it's capital P, and we do not know because now we need to find it. What is the annual interest rate? Little r. Well, in the statement of the problem, we know that annual interest rate is 12%, and let's convert it to a decimal, 0.12. How often are you going to make payments? Well, we would like to know, actually we know that we're going to spend $200 each month. So little m is going to be 12 because there are 12 months in a year. How many payments are we going to make? Well, we're going to make payment each month for 4 years. So little n is 4 times 12, which is 48. How much is a regular payment? We know it's big R because we're going to spend $200 each month. So 200. Again, we substitute all known variables into the formula, keeping in mind that little r is 0.12, n is 48, m is 12, big R is 200, and we need to find P. So after substituting everything into our formula, it looks like this. Again, we need to simplify this expression. First, we compute R over M, because this quantity is present 3 times in our formula. In this particular case, 0.12 divided by 12 is 0.01. Okay. Now we can simplify a little bit further. We compute 1 plus r over m to the power n. R over m was computed in the previous step, so we just need to add 1 and raise the quantity to 48th power. And we get 1.61222 and so on. Again, please do not round until the last step of the problem. With this, we get this quantity, but we need to find P. So how do we isolate P? Well, you divide both sides of this expression by the number that is next to P. So P is $7,594.79. So suppose that you have $220,000 remaining on your student loan with an annual interest rate of 10%. You wish to pay off the loan in 10 years. Assume that you can refinance your loan at 4%. It really can happen because usually when you're a student, you do not have a good credit score. And if you need more money and government loans are not enough, then you can actually go to a bank and ask for a private loan. And that you will pay off that private loan as a regular payment, as a regular loan. But maybe after some time, you made all your payments on time. You never missed a payment. You also have a credit card with excellent score, and so on and so forth. So you can actually call either your bank or maybe some other bank and say, well, can you give me, let's say, $100,000, and they $20,000, I'm sorry, and they can say, yeah, sure, and we're going to give you 4% interest rate. And you say, well, it's less than I'm paying right now, so maybe it makes sense to refinance my loan. So we need to answer several questions to see if it makes sense to refinance your loan. What are your monthly payments on the original loan? How much will your new monthly payments be? And how much interest will you save over the 10 years? So we're going to use the following table that gives the monthly payments of $1,000 loan given the interest rate and the length of the loan. So we know that we have 10-year loan and annual interest rate is 10%. So we look at the column that corresponds to 10-year loan and annual interest rate 10%. In the intersection of that row and that column, you see 13.22. This is your monthly payment for each thousand you borrow. Since we still owe $20,000, we need to multiply 13.22 by 20. So our original monthly payment is $264.40. Now, if we refinance, you're taking out a 10-year loan for $20,000 at annual interest rate of 4%. So let's say we're going to use the same table. So in the intersection of column that corresponds to 10-year loan and row that corresponds to 4% annual interest rate, you see that there is $10.12. Since you're going to borrow $20,000, you need to multiply 10.12 by 20. So if your interest rate is 4%, not 10, your monthly payment will be $202.40. So let's consider two situations. Let's say that you did not refinance your student loan, so you're going to pay your original amount, $264.40 for 10 years, or 120 months. You will pay a total of $31,728. In case you decide to refinance your loan, your monthly payment now is going to be $202.40. And if you multiply this quantity by 120, you see that for 10-year period, you will pay $24,288. So the difference, which is $7,440, is the amount that you will save on